Hello students, we are learning lesson number 9, force and laws of motion, and today we are going to learn about Newton's second law of motion. Already we understood the Newton's first law of motion. Now it is second law of motion, and this is video 4 of the chapter. So it can be asked in the question form: state Newton's second law of motion and derive the formula for calculating force. Actually, Newton's second law of motion gives the formula to calculate force. Let us see the statement of the law. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. The rate of change of momentum of an object is proportional to the applied unbalanced force, and this rate of change of momentum is in the direction of the force. This can be understood in this way. Now let us recall what is momentum. Momentum is the product of mass and velocity. It is the product of mass and velocity. It is denoted as P. P is equal to mass into velocity. It's mass into velocity. This way we define momentum. Initially already I have explained you what is momentum with an example. For example, say that means momentum depends on the mass of the object. Momentum also depends on the velocity of the object. And if the mass of the object increases, the momentum increases. If the velocity increases, then too the momentum increases. Momentum means the effect of force felt. The effect of force felt is depending on the mass and velocity both. Now suppose we are throwing with the hand. Throwing an object with the hand, that is with the initial velocity u, and the mass of the object is m. So the initial momentum of the object will be, that is mass into initial velocity, m into u. And now the same bullet, we are throwing the bullet with the hand on a person. If I throw the bullet on a person, the person will not be scared because the velocity of the bullet thrown with the hand is very, very low, and the mass of the bullet is a very small thing. So the effect of the force will not be realized so much that the person gets scared. Now if the same bullet is thrown with the gun, if it is shot with the gun, the mass of the bullet remains the same, but the velocity increases so much that the gun can pass through the body of the person, killing the person. It is such a high momentum is there because the high velocity. That means the effect of the force felt by the bullet is too much. It can kill the person. So in this case, the initial momentum of the bullet was mass into u, that is mu, that is pi, and final momentum p2 is m into v. And why the effect felt is more? The effect felt is more because there is change in momentum. Initially it was less and then it is more. And why there is change in momentum? Because the force is applied by the gun. Force is applied by the gun, and force is applied by the gun on the bullet for a shorter period of time. So we can say change in momentum is P2 minus P1. It is denoted by triangle means delta P. This is called change in momentum. And actually force is directly proportional to the rate of change of momentum. That means effect of force felt is because of the change in momentum. Initially the effect of force was less. Now the effect of force is too much. And that too when the bullet is fired from a gun. Gun takes a very less time, very short time to fire the bullet, to shot the bullet. So when the time taken by the gun is less, then the effect of force felt because of the bullet is much more. And this is change in momentum, and we can state the sentence. Now from this formula you can speak out the law like rate of change of momentum. Rate means change of momentum divided by time taken. So rate of change of momentum, go from the denominator to the numerator. The rate of change of momentum is directly proportional to the applied force, and this rate of change of momentum is in the direction of the force. Is in the direction of the force means when the gun is applying the force in the direction of the bullet to be shot forward, then the change of momentum will be felt in the forward direction only. So this formula is spoken in the statement form in the second law. See the formula. The rate of change of momentum. See here. Rate of change of momentum. Rate of change of momentum of an object is proportional to the applied unbalanced force. That means as much force will be applied, that much the rate of change of momentum will be there. And in the direction of the force. In the direction means what is in the direction? The rate of change of momentum is in the direction of the force. And this statement is written in the formula form in this way. So the same situation we are going to explain in the statement form. This, as I explained you, see in the statement form how to write. This is the law you have written and derivation of the formula. Suppose an object of mass m, say the object is bullet. Okay, say the object is bullet, it is having mass m, is moving along a straight line with an initial velocity u. As this is the first situation, that the object, that is bullet, is moving with initial velocity u having mass m on a straight line. With an initial velocity u, it is uniformly accelerated to velocity v in time t. Uniformly accelerated means when the velocity increases, then there is acceleration. And it is uniformly accelerated in time t by application of a constant force F and throughout the time t. So the initial momentum of the object Pi is equal to m into u. Final momentum of the object P2 is equal to m into v. So change in momentum is delta P is equal to P2 minus Pi. So according to second law, the rate of change of momentum is directly proportional to F. This can be written as force is proportional to delta P means P2 minus Pi, final momentum minus initial momentum upon time. F is proportional to P2 means mv. So P2 is mv and P1 is mu. So you write mv minus mu upon t. So F is proportional to take m as common and the bracket v minus u upon t. But v minus u upon t is the formula of acceleration. So we can write the a is equal to v minus u upon t. So F is proportional to m into a. How m into a? See, F is proportional to m into v minus u upon t is a. So F is proportional to m into a. Now to change the sign of proportionality to make it a perfect figure, we give the proportionality constant. F is equal to k ma. K is constant of proportionality. Now to make the value of k as 1, we have to take mass as 1 kg, acceleration as 1 meter per second square, and then the force will be of 1 Newton. If mass of the object is 1 kg, if an object of 1 kg is accelerated by 1 meter per second square by applying 1 Newton force, then the value of k becomes 1. So unit of force is so chosen that k becomes 1. So 1 unit force, that is 1 F is 1 is equal to k into 1 kg into 1 meter per second square. Thus the value of k becomes 1. So we have the formula F is equal to k. Instead of k we write 1. Now already we have k is equal to 1. So F is equal to ma. Thus second law of motion gives us the formula to measure force. So F is equal to m into a. What is the formula? Force acting on an object is the product of mass and acceleration. That's all in today's video. We'll be meeting in the next video.